Now we are going to discuss another process of data transformation, which is standard scalar, and this is the process called as standardization. We have already seen the normalization. In the case of normalization, the data was changed to the range 0 to 1. Now in the case of data standardization, it is up to you what range you want to create for your data. And in order to perform this data standardization, we have standard scalar in Python. So standardizing our data involves rescaling a distribution of values. So distribution of values here means the input. So you take the input and you rescale it so that the mean of a observed value is 0. See here, now you have to create your data in a way that your mean will be 0 and standard deviation will be 1. So this is what standardization means. Now in order to do this, in order to make your mean 0 and standard deviation 1, what you need to do? You need to subtract your data by mean value or centering the data. So you need to subtract your any data with the mean value. So this is the first step. Like normalization that we have already studied, standardization can be useful and even required in some machine learning algorithms when your data has input values with differing scale. Standardization assumes that your observation fit a Gaussian distribution, something like this bell curve. If you remember, this is standard distribution. So it assumes that your data follows this distribution and it has well behaved mean and standard deviation. You can still standardize your data if the expectation is not met, like if the data is not bell-shaped curve, but you may not get the reliable result. So in order to get a reliable result, make sure that your data follows this Gaussian distribution. Now how to check if the data follows Gaussian distribution or not? So for that, you can use the concept called as a histogram. You can plot the histogram, and if the histogram looks something like a bell curve, bell-shaped curve, something like this, where your data will have multiple bins. So if you plot, and if your histogram looks something like this in the bell-shaped curve, then you can use this standard scaling approach. So if it looks something like this, it must not be like exactly the same. You can just have different values, but in all it should be quite similar to the bell-shaped curve. Now if you get something like this distribution from your data, then using standardization is a better approach. Otherwise you can also use the normalization. Now this is the formula to perform the standardization. So if you want to learn about the standardization, it is better to take example and we can see how it works. So let us say that I have the data. I'll just take a simple data 1 2 3 4 5. Now can you calculate the average value of it, which is nothing but a mean? Can you calculate it? So you can just add all the numbers. Since they are a consecutive number, you can also say that 3 is our mean, but you can do this way. So you calculate all these numbers, just add it one by one, all of these numbers, and divide by the number of these, that is observation. So count it 1 2 3 4 5. So there are 5 numbers in total, not the number 5 only, but all of them if you count one by one. So they are 5 in numbers. There are 5 observations. So now if you calculate this, you will get the value 3. So the mean here is 3. Now you can also calculate just the standard deviation if you want. So just calculate the standard deviation over here. So you can do something like this. You take each of the observation and subtract it with 3. Take each of these and subtract with 3, something like this. So take the first observation and just square it and take the second observation and subtract it with mean. So second observation, subtract it with mean, square them. And similarly, take third observation, subtract with mean and square them. Do it for all the observation till 5 in our example, and divide it by n minus 2, or just divide it by n for this example, let's say. So how many observation are there? So 5. So in this way you can calculate the standard deviation, which is nothing but a observation that has been deviated from the mean. So standard deviation tells us what, so standard deviation tells us by what amount our data is deviated from the mean. So that is what our standard deviation tells us. So using these two values, now we can perform something called as standardization. So see here, this is the example. So this is the formula for standard deviation. You take the data that needs to be standardized, you subtract it with mean and divide with by standard deviation. So this is your normalized or standardized value. So mean is calculated this way and standard deviation is calculated this way. You can see the formula right here. You do not have to do it. It will automatically be done by the computer, by the algorithm. So there is some library to perform that. For now, you can take a simple example. Let's say that we estimate the mean of 10 and we estimate the standard deviation of 5. And this will be calculated by the algorithm. Now, let us say that we can standardize the value 20.7. So I need to standardize this value 20.7. So I can use this formula. So in the case of x, I will put 20.7 because this is the number that needs to be standardized. I'll just take that number, subtract with the mean, and here we calculate the mean of 10 and divide it by the standard deviation of 5. This is also calculated. Now after you calculate this value, you will get 2.14. So this is the value. Now this value represents that you have a mean, you have a center at 0 now, because you won't be doing only for the x of 1 values, you will be doing for all the columns or entire columns, and that will make your center at a mean where the mean is equal to 0, and that is what standard scalar represents. Now you can see the bigger value has been standardized to the smaller value. So in this way we can convert all our larger values into some standard scale. And we have already seen what is the advantage of doing this. Obviously the advantage of doing this is our machine learning model won't be biased toward the higher values. Now all the values, the larger and even smaller, will be treated equally by the machine learning algorithm. So that is the reason we need to perform a concept of data transformation, where we study two types of a concept. The first was a normalization, and normalization is also called as min max scalar, because if you remember the formula, we use something like this formula. So x of normalize is equal to take the x and subtract it with minimum values and divide it with max minus mean. If you remember, this was the formula, and we use the concept of max and mean within the formula. So that is the reason we call it as min max scalar. And similarly, we just studied about the standardization, and to perform the standardization we have something called as a standard scalar. Now standard scalar will calculate the standardized value for x by the formula x minus mu. Here mu is a mean, divided by sigma. So sigma here is a standard deviation, which tells us how much far our data is from the mean, and mean here is an average value. So this is the average value and this is standard deviation. This is the data that needs to be standard. So this way we can use these two algorithms in order to make our input into some standard scale, which will eventually increase the efficiency and accuracy of our machine learning algorithm.